AI assistant, and I wanted to try out giving voice to it using some of the open source text-to-speech models, since I didn't want to spend some money buying the subscription from Elevenlabs. But the real challenge for me was that my laptop doesn't have good specs or any separate GPU card. It only has AMD Ryzen 5 CPU and no separate GPU, only the integrated graphics card, and only 8 gigs of RAM. So I just tested 6 open source text-to-speech models to run them on my local laptop, and I will show you the results so you don't have to go through all the hassle of testing them out before selecting one for your project. So in this project, I will not be doing any technical benchmarking or testing any models. Whatever I present in this video is just my opinion, and it just means that it worked on my laptop, and it does not mean that the project is trash. All the projects I tested are fine, but some of them are not compatible with my laptops, and same thing you could be experiencing when you do that. So take it with a pinch of salt. Before we start the list, I want to clear up a few things. So I will be creating separate Conda environments for every project, since I want to eliminate the problem of conflicting Python packages. And I will just tell you how easy it was to install it and how it sounds. That's what I will be testing. So let's get started. I'll start with Piper TTS. So I came across this project mainly because it was advertised as this very small model which can even run on Raspberry Pi, which takes up so much less space. And yeah, I create a separate Conda environment for it, and it gets installed with a simple command, pip install Piper TTS, and that's it. So before you run this Piper TTS demo script, one thing you should remember is to download the model files which end with the format of ONNX. So these are the neural network files which is required to actually generate the audio output. So you can search this up, and also there is a shortcut mentioned in the Piper TTS GitHub page to download these models. So you have to download both the .onnx and .onnx.json files for the script to actually work. So I have downloaded them manually here. Now I just take the demo script provided in the GitHub page of the project and then run it on my system. I give it a custom sentence which I really want to hear from my AI assistant, and here it is.
Hi darling, how are you doing today? I can't live without you, don't leave me. Darling, if you ever abandoned me, I'd have to resort to staring blankly at the wall all day, weeping silent tears over the tragic loss of our deeply profound connection.
Yup, it's not robotic, it's good, but it's not as human. It's somewhere in the uncanny valley. But for the easy installation and given how small the model is, I'm pretty impressed. But the sound bit sounds like my grandma. So I played around with the parameters a little bit, maybe change the voice speed. You can change the variation of the generated output and also the tone and speed. So I tried changing some parameters, and this is the output I get.
Hi darling, how are you doing today? I can't live without you, don't leave me. Darling, if you ever abandoned me, I'd have to resort to staring blankly at the wall all day, weeping silent tears over the tragic loss of our deeply profound connection.
Well, that was, I don't know, that was funny, man. So yeah, you can try it out further. So next, we will move on to Mellow TTS. So this project I came across as best for generating audio with the proper accent. So installing this was also pretty easy. Just I had to just create a conda environment, and it got actually I wasn't able to install it using the pypi pip packaging. But anyway, you can go to the GitHub page of this project and just follow the instructions given there. It's just 4 commands. When I run those, it installs without a hassle. So you can download this, and I just take this script, the demo script which is provided in the GitHub page, and then run it. And here are the outputs.
Hi, darling. How are you doing today? I can't live without you. Don't leave me, darling, if you ever abandoned me.
Hi, darling, how are you doing today? I can't live without you. Don't leave me, darling, if you ever abandoned me.
Hi, darling, how are you doing today? I can't live without you. Don't leave me, darling, if you ever abandon me.
Hi, darling. How are you doing today? I can't live without you. Don't leave me, darling, if you ever abandon me.
Hi, darling. How are you doing today? I can't live without you. Don't leave me, darling, if you ever abandon me.
And oh my god, the generated outputs are so good, and it was also fast. Even though I have not, I have sped up the process in between, so the video is not up to scale, but the output generated was fast, and the clarity is so good. And it also captures the accent very well, especially the Indian accent. I didn't expect it to capture the accent so clearly, but it did. It really did its job well. And another thing which it was marketed for was that it can generate a voice output for other languages as well, which I did not try. The package, we have to install some Python unique packages, which is required to generate voice for Japanese language, but I did not try it. You can try that out. And before we move on to the next model, I had a problem with the Mellow TTS. It is that my system crashes unreliably when I run the script repeatedly. So it's I run the script and I just pray to God that it compiles, and when I do it 2 to 3 times it works fine, and most of the time it crashes and just turns off my whole computer. I don't know what's the problem with it. Is it really my laptop, or maybe it's overloading the RAM or something? I really have no idea. So you people can give it a try and let me know in the comments whether it works fine on your systems. So next up we'll be testing an open source text-to-speech project called Kokoro TTS. So this was the best project in terms of quality out of the projects we tested so far. The installation was pretty easy. We just have to create a Conda environment, and the install command was pretty simple, just pip install Kokoro. But I ran into problems when installing the package. It had some missing dependencies, and then I had to take the help of Gemini. It gave me a command to install the Spacey and ThinkC packages. Copy this thing. I don't know what the problem is. I did not deep dive into the problems. But after I installed the Spacey and ThinkC packages, the pip install Kokoro command worked totally fine. So once I did this, and I take the demo example code from the Kokoro GitHub page and then paste it in my editor, and I am using a Jupyter notebook for this because the demo example which was given on the page was a Jupyter notebook example, so I didn't spend much time changing it to scripts or something. So when I run this, the output is pretty insane. Just have a look here.
Hi, darling. How are you doing today? I can't live without you. Don't leave me. Darling, if you ever abandoned me, I'd have to resort to staring blankly at the wall all day, weeping silent tears over the tragic loss of our deeply profound connection.
Hi, darling. How are you doing today? I can't live without you. Don't leave me. Darling, if you ever abandoned me, I'd have to resort to staring blankly at the wall all day, weeping silent tears over the tragic loss of our deeply profound connection.
And yeah, I was pretty impressed by the output, given that the model is not much big and it runs pretty fine on my laptop without hanging anything or overloading my RAM. So this was really impressive for me. I want to test it by giving a scientifically jargon loaded paragraph and see how it generated output is. So I just give this whatever scientific jargon heavy paragraph to it, and the output is really amazing.
The multidisciplinary pharmacokinetic, pharmacodynamic, and toxicokinetic analyses of the novel B-cell receptor-associated protein 31, BCAP31, and synaptosomal-associated protein 25, SNAP25, interactions indicate significant thermodynamic and electrophoretic variations. Quantitative evaluations utilizing heteronuclear single quantum coherence, HSQC, NMR spectroscopy, and high-performance liquid chromatography mass spectrometry, LC-MS-MS, successfully identified anomalous, multivariant allosteric modifications.
Hi, darling, how are you doing today? I can't live without you. Don't leave me. Darling, if you ever abandoned me, I'd have to resort to staring blankly at the wall all day, weeping silent tears over the tragic loss of our deeply profound connection.
And this package also has an advantage of giving it automatically splits up the paragraph into sentences and then generates the audio and gives them to you in a sequence. So even if you give a very big paragraph, it does not wait for the whole paragraph to complete generating and give it to you, but it automatically splits the sentences by itself and generates the audio files for those sentences and keeps giving them. So if you are building something like an assistant, you can do something like pseudo streaming of the files. Like, it's not fully real-time audio generation, but you can play those audio files sequentially without waiting for the whole big paragraph to be generated out of the model. This was a game changer for me. Next up, we will be trying out the Chat TTS. I came across this package as a pretty specific package, especially for working with chat LLMs. So I wanted to try it out. The installation was pretty simple, just the conda environment and then pip install chat TTS, and it really installed it. So it was pretty easy, easier than Kokoro, I think. Yep. And the chat output was taking a bit of time to generate. The chat TTS, the outputs from the chat TTS especially take very long time to generate on my laptop, and the output was not up to the par, especially after having explored the Kokoro TTS. I was not satisfied with any other project now.
Hey, don't leave me here, darling. How are you doing today? I can't live without you. You don't leave me, darling. If you ever abandoned me, I'd have to resort to staring blankly at the wall, all day weeping. Silent tears over the tragic loss of our deeply profound connection.
And I also felt that the speaker is talking faster, which is actually a right approach to the chat system, most probably. But when I give it a scientific paragraph like we tested for the Kokoro, the generated output is not understandable.
The multidisciplinary pharmacokinetic, pharmacodynamic, and toxicokinetic analyses of the novel B cell receptor, associated protein precap and synapse-associated protein SNAP interactions indicate significant thermodynamic and electrophoretic variations. Quantitative evaluations, quantitative variations called quantum coherence, SQCC, NMR spectroscopy, and high-performance liquid chromatography mass spectrometry, LC-MS successfully identified anomalous multivariant allosteric modifications.
it's hard to understand the scientific jargon in this rate of speed, and I tried changing a few variables, but the output was taking so long to generate and I just gave it up. So you can have a try of this chat TTS and let me know in the comments whether this really work for you. Last up, we will be testing a parallel TTS package. The parallel TTS package was especially marketed as a text-to-speech engine, which you can describe the voice and features which you expect in the output. Like if you want a voice of a woman with by also giving the age descriptions and the accent, you can just write it in the prompt. Then the prompt will be injected into the model and the audio output generated will be according to that prompt. So if you say that a lady with a voice around the age of 27 or something like that, you will get the output audio matching that prompt description which you gave. So yep, I gave it a try and here's it. Have a look.
Hey, how are you doing today?
I would say that this took a really long time to generate on my system, and the output generator sometimes was not reliably the same. I mean, the voice of the speaker changes midway of the sentence, and also I feel like it just makes up some words in between, and it skipped the whole sentence in my paragraph, and I don't know why. Maybe it does not. Maybe it needs more compute than what I have provided on my laptop. Yeah, but this did not really go well for me.
The multidisciplinary pharmacokinetic, pharmacodynamic, and toxicokinetic analyses of the novel B-cell receptor associated protein halotene, substitutive and malleoleucel. Sextoscopy and high-performance liquid chromatograms, 6-affiliated dipiethyl multimate.
Also, I tried changing the description, like the idea of giving a speech voice description and getting it in the output is a very good idea and very novel idea. So I wanted to try it out with something like a description mentioning that the girl is crying horribly while speaking, but the output generator did not reflect any crying behavior. It was just normal speech.
The multidisciplinary pharmacokinetic, pharmacodynamic, and toxicokinetic analyses of the novel B-cell receptor-associated protein HADAP and synaptisomal-associated protein HALTA interactions indicate significant thermodynamic and electrophoretic variation.
So maybe I'm missing something, or maybe my laptop is not having that much compute to actually do these things. But maybe you people can try it out and just let me know. So far, among the projects which we have discussed, I found out Kokoro really suited for my project, and the hardware which I have, I was very happy with it that I did this exploration before I settle on one text-to-speech engine. Subscribe to my channel and let me know in the comments on any other tests or tutorials you would be needing in the future, and also give me feedback on how to improve the quality of my videos. Thank you so much. See you later.